Hello, welcome to Steve's World. Sunday on Father's Day. Tonight we'll be discussing my experience with alternative energy, also free energy. But before we do that, I'd like to remind everyone out there to come to the 2022 Extraordinary Technology Conference in Albuquerque, New Mexico, August 10th to 14th. Now's the time to register. We have a 30% discount for people who sign up right now. Um, and then we'll also take in uh, we have our rooms at $82 a night for one, 80 it's 86 for two. That includes a free breakfast, which will be a buffet breakfast, a full buffet breakfast. You can't go wrong on this, people. If you're interested in alternative energy or alternative medicine, this is the place to be. You get to meet real people, live people, and I think I know you'll have a great time. And I'd like to get over to sign up for the Test of Tech YouTube channel if you haven't already. I'd like to thank Scott for joining. Uh, I believe it was I think it was yesterday. Uh, everyone, every member helps us. And without further ado, and we'll come back to this later. Uh, I'd like to go right into our main program, the Kipper motor. Now, the gentleman up on the right there in the tan shirt, his name is Kipper. And Kipper, he was a friend that lived in the outback of Arizona. For those people who don't know anything about Arizona, when you live in the outback, you have to haul your own water. You just don't, we don't have a lot of wells out there. And what will happen is you have to take in a truck, with a tank on it. You put a tank on, plastic tank on it that can carry about anywhere from 100 to 300 gallons, and you haul that to your house and you dump it into a tank. Okay, that's the way we live out in the outback. When and a lot of places in the outback there is no uh, uh, electricity to speak of, because it costs a lot of money to to pull an electric line, in the middle of nowhere. Where Kipper lived, it was on the edge of the Maricopa and Pinell County line, and the local law enforcement guys would not even go out there because uh, they couldn't tell where the the county line was. Now, remember, now this is in the days before we had things like GPS, and and this is by Stanfield, Arizona. And Stanfield is on the main route, for the undocumented people coming in uh, from Mexico there. Anyway, Kipper, I'd see him over when I went to the uh, Circle K store across the street from where I had my office at that time, and he was be telling me about how he was able to make a free energy device, and I guess using a pintle fan motor, they were able to observe OverUnity results. And he also built, some OverUnity devices that he used out there, uh, and to live with, And basically, it's a very simple device. He come over one day and says, "Here, we'll build it right now." So we go over to Napa next door, and we picked up an alternator, the cheapest alternator we could find, because we don't have a lot of cash. Cash seems to be a big problem. Uh, it's one of those life problems, you run into all your life. And so what we did is when we went and got this alternator, and we picked up these little packets, of little packets of green wire. They come like little rolls. They're used for wiring vehicles and that. And they're high amperage, well, fairly high amperage. For a guy like me, I'm normally work with logic circuits, so I'm used to micro amps as opposed to amps. But anyway, we went and we picked up the wiring and everything, and uh, and then we went to Phoenix to Granger and picked up a little 3 amp per mag motor. Uh, and what we did is Kipper's there, and he's saying, "Okay, well, let's get to work." So we went and we found these metal boxes laying around in the shop there, and we put the boxes. We made little cross bars on the boxes so that we could take and we could mount uh, the uh, the items to it. The alternator and the little per mag motor. And then we had this little bitty three V belt there that we ran between the two. Uh, I wish I could magnify this, but I really can't do too much on this. Uh, but there's a picture of it uh, with the battery in the foreground. Was a dead battery. When we picked it off the floor, it was just laying around the shop there. It had like about 8 volts. So we opened up the lids there. We poured some water in it. And then we started wiring it. And Kip would take these rolls and he'd pull it out like this. Well, those wires were about 6 feet long because Kipper, he's a little bit over 6 foot. And the sacred geometry, your wingspan is equivalent to your height, in a human. Anyway, so he took the wires, he did 4 of them, and then he let them spring back together as a coil. And you can see in the drawing there that it's all coiled up there. And you can see the little alternator and the permanent motor in the background of that picture there on this page here. And I'm going, gee whiz, this is the sloppiest wiring job I've ever seen. I mean, we already had to go about what, maybe 6 inches or so, and here he has 6 feet of wire and everything. So we wire it all up and everything, and the motor's trying to go. Once we get it wired up, it's like, you know. And so what happened is then uh, Kipper looks at this, and it's still going. And I took and I was just twisting the alternator, to get some momentum to it, to get it over the resistance there, and it just started going, just barely moving. Kipper looks at that and he goes, "But this ain't right." And he gets in there, and he just starts spreading those coils around it with his hands, and all of a sudden, snap! That motor took off like you would not believe. It was like it's starting to whir and whir, and nothing was getting hot. You normally expect to get things to get warm, but it wasn't getting hot at all. And if you looked at the battery's just bubbling away like crazy and everything, right? And it's like, wow, this is this is insane. Uh, and we went away for about 2 hours. We come back and we checked the voltage on the battery. It went from like 8 volts to 14 volts in about 2 hours. And it's still just boiling away. And I'm going, dang, Kipper, if we don't put a load on this thing's gonna blow up on us. So we started by pulling one of the wires, and then we took and he brought in uh, an inverter. We put the inverter on, because inverters suck up some of that energy. We put a 100-watt light bulb on that device, and then we put it on and off switch in there, and we flipped it on, and man, it just took off. It's like, wow, this is crazy. And we were measuring at that point 3 amps in, 30 amps out, you know, and going towards the battery, and it was like, I'm just going, wow, this is impossible. There is no way that you could do this now because I'm an electrical engineer. I know all my equations and that. And the only thing that should have happened is that the motor should have gotten hot, and and the and the what was left in the battery should have been dragged down even further. But that did not happen. What happened is it just kept going away faster than ever. We had 100 watt light bulb there, hooked to an inverter. Didn't make any difference. It didn't make it go faster. It was the motor was cold, and it was almost like the alternator was pulling the motor along. It was just strange. And so we went to the auto parts store and we got one of those little ammeters that you have on your car, for it's directly measuring the current and everything. We turn the thing off. We go to put that in the circuit, and just as we try to put it in the circuit, that little ammeter just blew up in our hands, and I was like, "Wow, this is crazy." Anyway, we kept this going. We drew up some plans, because we just to cast me out here, you know, and here's the plans that we drew up. This is the schematic there. As you can see, it's very simple. You have your motor, you have your alternator, you know, you have your battery, and you had like one wire goes from the alternator output to the battery. Then you have the other one going from the positive terminal to the output. And we had the voltage regulator hooked in there, I think. And then we had the DC motor, a little DC motor. And we had a parts of this, The battery used was a Trojan 12-volt deep cycle, you know, which you use for RVs. We have our little on-off switch there. And the plan was to take the output, and go to the house, you know, and this is what we built. Um, I thought my biggest mistake was when I drew these plans up is that I didn't think the wires were that important. I thought, we could get probably really short ones than that. But I believe at this point that those wires is the whole piece of this thing. When Kipper did this, um, when it didn't run right, and he goes in there and he's starting to separate, and he's out in there separating those wires. Okay, what he's doing when he's separating them, what he's doing is changing the impedance on those wires, and and being 6 feet, um, wires. What he was doing is he was taking and um, and altering and if you look at them as antennas, you have an aperture. And that's where you can receive your signals and that, and you want to have get maximum impedance matching there to get the maximum transfer of energy. Well, somehow at 6 feet, it seems to click on this thing, and it took off like a bat out of hell or a banshee. And when they did, um, when he did that, um, it's telling me now in reflection that there's a band of energy. Okay, we have a band of energy that permeates the space time here that we can tap into with a 6 foot aperture. I believe that this is what Tesla tapped into. When you read his account of the Pierce Arrow, uh, a car in they test drove in California, it talks about a 6 foot antenna. If you go in and you look at these old radio manuals and everything, they tell you never touch a 6 foot antenna because it'll kill you. Well, I believe that our device was receiving energy through the 6 foot antenna, those coils there, and that's what was running it. The problem is this thing ran for 3 weeks, 3 weeks, and then it died. You know, and as it was dying, I knew something was wrong because we had this press lady there, and she was taking pictures and everything because it was going to be in the newspaper. Well, it died right there, and as it was dying, all of a sudden the motor got extremely hot, burnt my hand, you know, and it died really fast, Um, Even so, it kept the 10-to-1 ratio. Uh, as it dropped down to all of a sudden 1 amp, and all of a sudden to zero, the output went like from 30 amps down to 10 and then to zero. Strange. Okay. So here we are. We've done drawing these plans. We're actually selling these plans because we thought that we had the casting out here. And these plans, uh, we were going to take and have other people sell them, build these things, and then we'd be able to help them with uh, with whatever was going on here. Um, I know of one person who succeeded in getting it, you know, and then about a week later he had a heart attack. But anyway, so I know one person was able to get this thing to work. It's very hard to get to work. Kipper seemed to have this little uh, knack for doing stuff like this, you know. Uh, but then all of a sudden, these guys come from out of town here. They're really interested in the motor and everything. And they told Kipper, look, you come work with us, and we'll give you all these millions of dollars to work with, and everything. And but the only thing is, you can't work with Steve. So he disappeared on me, and being that he lived in the outback, I knew he'd come to my place sooner or later because he had to get water. And behind my shop was the sweetest water in the county, a really super deep well. The water was ice cold and very clean. You know, just what you need when you're going to take and you know haul your water. So what happened is he told me then exactly what was going on in that, and so he kind of like disappeared for a long time. Meantime, I'm out here trying to figure out what's going on. Uh, we were looking at orientation of the alternator versus the DC motors, if they had anything to do with it. We were also looking at the different types of wiring and everything, but it really didn't get to do what we wanted to do. And what we really needed uh, would be some kind of frequency analyzer for starters, and to have possibly some kind of impedance match, box where you could change your impedances and step through it. Now, if you jump back to HARP, I don't know if anyone of you ever heard of HARP. Uh, HARP was a big antenna array they had up in Alaska to look into getting this information, or getting energy from the aurora and everything. HARP is high. Uh, it was built on the aurora and the natural auroras that we get from the sun. Anyway, they at one point on their system, they stepped through all the frequencies on this antenna, and at one point they hit a frequency um, where it actually came into the antenna and destroyed everything, and they weren't expecting that kind of energy to come back out of the system, because normally on an antenna you put energy into a system and it goes out. So so I would just love to have that frequency that happened to them on. I would imagine that might even have something to do with the frequency we saw here that actually operated this motor. Anyway, Kipper disappears. He goes off and works with these people, and he worked with them for I don't know, about a year. And then out of nowhere, I see this note where they're going out there and they're spread it on the internet, that hey, Kipper's a fraud. He's doing this with microwaves and everything. And I knew, I knew that this was not true because first of all, to transmit that much power uh, to the device we built, he would have had to have a source, and that would have been his truck, and would have had to fit underneath the hood of his truck. And he drove a Ford Ranger, which is a pretty small truck. And for him to have that small of a transmitter to put that much power out, that would mean that that would be an achievement in and of itself. You know, so it was just a bunch of nonsense they were spreading. Um, so I wrote a letter out to the internet, telling them about my experience with them and supported, Kipper's claims and everything because I built one. And I know what I saw. I know what I experienced, and it's just not me. My wife, she saw it. The news lady came and she saw it. Other people saw this. Up until the 3 week period when it died. Um, so then I had moved about 100 miles from there, and I get a phone call, and it was Kipper. And he thanked me for supporting him, his honor there. And he told me, that they had built bigger ones, you know, a lot bigger ones, but they kept running into a 3 week problem. And instead of sitting down and figuring out the 3 week, what the 3 weeks was all about, they took the approach of taking and denigrating it and calling them a bunch of names. You know, um, I mean, this because of this experience. Okay, I am a believer in free energy. I know it exists. I don't have to believe anymore because I know. I'm like a doubting Thomas who actually put his hand in the side of Jesus. And and I don't know what else to say about this. Except like I would encourage everyone to try this. Okay, um, I believe that this is what Tesla worked out. I think this is what he found. I know that he said that his biggest mistake is that when he thought he had to charge the atmosphere to get the power out, but the power was there already, and that was his biggest discovery. Uh, but one of the things I want to offer tonight is I will make these plans available for free to anyone who has an exclusive membership on the Tesla channel. Just contact me at Steve at TeslaTech.info, or you can call me, you know, after this broadcast at 520-463-1994, and I'll send you the PDF if you're a member, uh, exclusive member, which is the 999 one. And the reason I would make it for exclusive for members is because members support this kind of research. Every time you put $1 into like going to a conference or memberships or even buying books, that helps us keep this kind of work alive. I could have done a lot more work if I would have had funds back then, but unfortunately I didn't. Um, Kipper, Marcus, he just had a knack about it. I was even asked like, "Gee, is this guy a witch or something?" Well, I'm not a believer in witchcraft. I know that this thing worked. You know, and I know that it has got to be something to do with those wires and everything. And there's something going on with that 3 weeks. Now, is it that when we tap into this uh, the space time fabric and we punching a hole in this thing that is kind of filling back up afterwards, like you throw a rock on a tar pit and it slowly is self healing and it repairs itself? Is that what we're doing? Do we have to do a thing like what they did with early radio, where they had like coherers? For those who don't know what a coherer is, it's like a tube. Okay, it's like a tube that is half filled, well, filled with loosely filled with like iron filings and that, so that it doesn't conduct electricity until you get a big voltage across, and then it lines everything up, and then it's like a wire straight through. They used them on the early radios, to decode these signals and everything, and then they'd have to tap it, you know, after you got your signal through, then you tap it to break that up again. Okay, that's called a decoherer. Uh, so coherence and decoherence. Is that what we need to do? What is it? So, is there another dimension? Do we actually tap into another dimension? You know, uh, I don't know. Uh, we need to look into stuff like this. We take a simple thing like this, which is a motor generator that should never work, and we and our plans we actually have a parts list, the exact part, and uh, and when you go and do this, um, you're going to learn stuff. Even if you fail, even when you fail, get something to work, you learn. And that's what it's all about. That's how come we have our conferences where people come and they bring their stuff. I encourage even if it doesn't work, tell us what you did. Because maybe if it didn't work for you, it might work for us, or maybe we won't have to go down that path or try it even. Uh, there's a lot of things going on there. You know. So anyway, if you guys have any questions, I'm going to put up the number if you want to come up on our stream here. Uh, and or if you just want to send out any questions or comments, to the comment line, I'm happy to answer any that you could think of. Yeah. So, has any of you out there built a device that works? And that brings up another thing, like with Tom Beard and that, he had the Meg device and everything. And a lot of these devices seem to work when you have faulty material, and the material's about kind of like falling apart. It works sometimes, and sometimes it doesn't. Uh, Semiconductors, you know, is an example where you have something that's doped up, and you have to put like a charge on it to make it conduct, and when you take off the charge, it won't conduct. Um, is that we need to use corrupted materials? This battery that we had attached on here um, is that 8 volts, you know, uh, and it almost seems like perhaps the battery is like the interface between this dimension and next. Maybe it's the chemical interaction that would cause, you know. And and Daniel Fauster asked, do we rely upon neon bulbs to instigate coils and motor resonances? Actually, this is a 100-watt light bulb laying around the house. I mean, there's nothing neon about it. The neon bulbs, you're looking at 12 volts and more like a micro amp. It would have blown up a neon bulb. So, uh, so that didn't work. Like I say, when you're doing this kind of work and you work in your garage, you got to rely on what you got. Here we have like uh, if you look at this box here, uh, pull those out of the scrap heap there. That little metal box there. Uh, about a dozen just laying around. Don't even know what they were for. They might have been like for a sine transformer or something. Uh, anyway, and yeah, I know the former workers at Borland's, Eric and Tom and that. And if you look at one of their old videos there on free energy, they have me as like a guest, at the lab the day they shot that. It was kind of interesting, and that's where I met Eric Dollar. And Eric has some really interesting experiences. Now he actually worked in the Integratron down in California, Los Angeles, California, uh, and he believes that that was a doorway into another dimension. And if it had been hooked up, he wasn't too sure, that we were ready for what would come out of that thing. And should we perceive that batteries are negative resistors? Um, you could, I suppose, um, I just had them as an energy source, but I think, we may have to relook at how we're thinking on this stuff. But like I said, these batteries, um, a lot of people are saying, well, that's where all the free energy comes from. Well, how do you account for the going from 8 volts to the 14 volts if that was true? You know, so the energy had to be coming from outside the system, and that's what the whole thing, on alternative energy is that the definition of what your system is. A solar cell, okay, could be considered a free energy device if you don't take into account that the energy is coming from the sun. And even then, I have some theories on how to really super increase uh, the flow of the energy from uh, uh, from the sun by using magnets on the back of this thing. On a solar cell, you have to have a 7/10 of a volt charge in order to forward bias and allow the energy from the sun to flow through that silicon. What if you put a battery behind that and you can induce a magnet behind that? You can induce that 7/10 of a volt using the Hall effect. Um, then all of a sudden, uh, all the energy that's coming from the sun goes into the circuit directly instead of being used to build up that voltage. Um, there's just all kinds of stuff. Um, anyway, we have a gentleman here who's talking about Eric Dollar, and the one thing I liked about Eric is when I was there at his show there, he had built like a Tesla coil, and with the Tesla coil, he fed um, on the input with the output of a record player. Okay, and he was playing Bach, and Bach has a lot of transients. Okay, in it, and and it was amazing how it filled the whole room up from just a single spark, and you could tell it was from just that spark, but yet would fill the whole room up. It's just really incredible stuff. Now, getting taking the transients that Tesla used, okay, he looked for the transients because anytime you have a transient, that's where your power for this type of energy is going to come from. Is that initial impulse there? You know, so Tesla, when he's building his coils on that, is driving it to hit that impulse to get that the energy back. And he considers the sparks, which uh, our Tesla coil builders love. They love making these big spark machines. But Tesla really considers that spark to be waste, okay? Wasted energy. Uh, all of our engineering that we have uh, in industry is geared towards dampening that transient, okay? That initial impulse there where these are spikes and everything. Everything goes to trying to get that down to nothing. They don't like transients because transients are unpredictable. They put a lot of energy in where it's not supposed to be in. If you look at like when they build these chips and everything, they're trying to get they don't want people to touch those chips because when you take it and rub your hands like that, you're generating at least 12,000 volts or more. I know. I've measured it. You know, um, when I worked for Unisys, formerly Sperry, uh, we put screens on our computer screens to take the energy coming off that screen and dropping it down. Because we had chips. We worked on chips on our desk. We didn't want to get that energy on those chips. Uh, just doing this to a chip generates enough electricity that when it goes in the wrong way in that chip, it will actually melt the aluminum uh, strips inside of there. Okay, um, I did the math on it one time. I've seen it. I've seen like when we take these chips apart and look at it in a microscope, you'll see like you have a strip of aluminum, and then it, like something hit it with lightning and that, and it ate a little hole. Well, each time electricity goes in through that pathway there, it gets hot, really hot, hot enough to melt that aluminum. Uh, and and we're just talking like on a little micro inch there. So what that would do is it eats that away, and then next thing you know, these chips are filling. It's called electrostatic damage discharge. That's to come if you go work in a chip factory or a place with a handle on it. You have to wear a strap, which grounds you to the uh, table there or to the ground. It keeps that from happening. Uh, this is the type of energy which can be utilized. Um, anyway, uh, this is a very real effect. I think that's like triple electric charging. And, and here's an experience Derpy had here. He rubbed his back against a wool recliner and popped his thumb against a steel wood heater, and the discharge hurt like hell and lit the room in a flash. So this kind of stuff, you walk across the carpet, you run into that. You know, if you have a big, if you, well, here you go, industrial high voltage, we switch aluminum for copper to lower the temperature. You know, but no matter what, when you're going from a big strip to a small strip, okay, it's just like when you take in a water and you go from a big pipe to a little pipe, all of a sudden you're going to have a high pressure. Same thing happens with electricity. Um, so all I can say is I encourage everyone to come to our conference because we have these kind of devices all the time. People bring in stuff and they will show you things that if you don't see, you won't believe it. And like I say, I'm not a believer because when we built the device on the screen there, the Kipper motor, it really worked. So I saw it work. Uh, I had the I had that ammeter, blow up in my hand, you know, and that's real stuff. So yeah, and here you go. Triple electric charging effect is how heat builds up the capability to generate its own plasma, and the Bernoulli effects. You know, yes, that's how it's a self-inducing plasma. And if you take in that tube that's inside of a gate device and you turn it backwards, all of a sudden you have a magnetic field that will resist uh, that being created. So let's see, what is that again? This like charges don't repel, but when they move together, they move together. It makes a tense electric field that disrupts the metal matrix and creates heat. What we're going to be seeing here in the near future is well, like right now, DARPA is trying to develop these electric drones. And with electric drones, you're going to need a way to charge them that they're looking at, and uh, and they're looking at using lasers. Like you have like your plane, you know, let's see, you have like your regular tanker plane. Only instead of pumping gas to it, it'll be shooting a laser into the drone and charging it up that way. You know, um, it's a corrupted uh, version of what Tesla wanted to do. Where Tesla would be using the worldwide power transmitter, okay, that he has built in Long Island to actually transmit power to planes, as they were flying. Well, this way here, they're trying to have like onboard batteries, and then charge the batteries up like they do uh, these tanker planes do for like these regular jets and everything. So, so there's a lot of stuff going on. I encourage everyone to come to the conference. I encourage everyone to become a member, uh, exclusive member of the YouTube channel. Uh, right now, we're putting up another 360 videos here in the next month, from exclusively for members. To the global science videos. If anyone I don't know if anyone knows what global science is. That was back in the late '80s, early and the '90s, and it ended in 2000 when the year after Dean died, because the people who tried to take it over didn't know how to run a conference. But uh, but anyway, we have all those videos going online, and you've got some really interesting people. Dean had 2 conferences a year, anywhere from 30 to 40 speakers at a time. So we have quite a few DVDs going up there, and material you're not going to find anywhere else on the web. And some of the stuff that your people are working with, like radionics and that, uh, these are the guys who um, who were the forebears, our forefathers in this kind of research. Anyway, and also like to remind everyone too, like this is Father's Day and everything. 4th of July is coming up soon. Right after 4th of July is Aaron's conference up in Idaho. Um, I'm not quite sure if he's full yet or not. You might want to contact him. I'll go on my website. I have a link on my schedule, uh, and you can click on it and take you to his website and give you his speaker list and all the information there. It'll be up in Spokane this time instead of Coeur d'Alene. Uh, so if you're flying, you'll be pretty, be a lot easier to get to than the Coeur d'Alene one was. About 40 miles shorter. Um, yeah, in fact, here's a fan right here. Check out the test tech and AMP. That'd be Aaron, and he spoke at our conference a couple years back. Very interesting stuff. So, like I said, like if anyone wants these plans here, uh, get a hold of me. I'll send you a PDF. Uh, these plans are like, I built this thing back around about 2000. It would have been 2000, yeah, 99 or 2000. It's a long time ago. Uh, Unfortunately, people who can do this kind of stuff, I don't even know if I could find a Kipper right now. I'd have to go down there, which brings up an interesting point. I come from Stanfield, Arizona, back in the day when we built this. About 10 miles from there now, they're building a brand new electric car plant. You know, and it's the most modern one of its time. So I'm about talked out here. Yeah. I also have a book called Tesla's Car. I try and get this thing to work right. I have this book here where I also have the plans in there, but I have other material in there about magnetic motors and that. Lee Scallion's work down in Florida and his material on it. The first book on magnetism by Presto Forgenis. Uh, the the motor that is built up in Canada, where you have a stationary ammeter there. You use like a fan blade to break the magnetic field, so the device thinks it's in a moving magnetic field and will produce electricity. So anyway, uh, with that, uh, does anyone else have any comments or questions? Oh yeah, and we may be doing a live feed from the conference. I'll let you guys know about that. Um, on maybe one or two of the presentations. So if I do, I'll be posting it, and we're looking at maybe having like a Zoom station where people could come in and just say hi, at certain times of need and that, when they're having the social hour. I'm hoping everyone can get there though, because there's nothing like being at a place in person. There's nothing like getting something in your hands. Right now, the next week I'll be going down to Casa Grande to pick up the programs. I hope it's this week, and then getting them in the mail right after that. And then because a lot of people, till you get stuff in hand, this is all fake. You hear everything's fake these days. Fake news, fake this, fake that. Come to the conference, try out the stuff. You know, even the medical stuff. Right now I have uh one of Phil Wilson's. He was a guest a couple weeks ago. I have one of his saunas here, and I'm trying out, and it's just amazing. And I have a hydrogen bronze gas machine here, and that will be at the conference. You sit down, try it out, see if it works for you. Um, I don't believe one size fits all on anything. You know. So anyway, um, yeah, energy is all around us. If you ever worked on like these industrial sized capacitors, like they use on these power poles and that, which you can't buy anymore unless you have a license, because the powers that be think it's so dangerous. Well, you have to take and you have to take and strap a bar across them, okay, to keep them brown, sorted out. Because if you don't, they pick up a huge charge in them. By the way, capacitors is what they were using to do a gravity detector, that measures fluctuations in the gravity field. So anyway, uh, I don't know who I'm going to have in the next week or so. I'm hoping to get my friend Bruce Broad up here one of these days. Uh, he hasn't been around for like ages, and he indicated he might be interested in doing something like this. So we will see. We will see. And Durfee, if you have this concept, we'd like to maybe hear from you. Maybe you might be willing to come up here and do a presentation someday. You know, uh, yeah. A lot of people don't understand. Like a lot of stuff that's given here because well, a lot of you guys are new to the field. Like Like right now, yesterday was my birthday. Makes me 67, and what really makes you feel old is when you look at your kids and they're in their 40s. It's like, wow, where'd all that time go? You know, where'd all that time go? So I want to feel free to contact me anytime. Um, I'm not on the show. My phone number is well, right there is my email, and my phone is 520-463-1994. That's our phone number. I'm here like 24/7. If you want to order something, I'm here all the time. Uh, and and Daniel, we'd love to have you come and do a presentation. And if you want to do it on anti-gravity only, that would be great. Uh, we cover all kinds of topics up here. You And without further ado, I'm just going to go ahead and call it a night and wish you all a happy Father's Day. Those of you who are fathers, and those of you aren't, have a great Juneteenth. For those who don't know, it's also the 70th birthday of the Special Forces today, uh, being formed. So, anyway, I'll see you hopefully next week. And you all have a great day, great evening. And if you get a chance, sign up to be a member and also take and come to the conference. We have a social hour every night. You sit down with all the speakers there, with everybody, and have a great time. Learn a lot. So anyway, without further ado, thank you. And here's more information. Oh, by the way, the little guy in the corner there, if you notice, he's looking at Tesla Tech on his video there. That was some doing. Anyway, have a great day.